Let us move on to part 2 of authenticating a Spring Boot application with Spring Boot version 3.1.0 with the help of spring-data-jpa. In this video, we will be adding the configuration details that is needed for security. We will be also adding the users to the database. So in our application, we need to create these classes. Since we need to add the user to the database, we need a model class. Let us have the class name as app user. We need a service layer and a repository layer. The repository interface is app user repository. In case of the service layer, we don't have to create an interface because this class app user service IMPL will be implementing the inbuilt user detail service. Already we have learned in case of in-memory authentication, we have used a class as in-memory user details manager, which is an implementation class of user detail service. In this case, we are creating our own class which is connected to the database for authenticating the users. So this is for the user part. In terms of configuring the application for security, we need to create a configuration class. The class name is webconfig, which is similar to that we have done in in-memory authentication. Now let us jump into Spring Toolsuite and start doing the coding part. The first step is let us create the user class. Select the model package, right click, new class. The class name is app user. If you notice, already there is a class with the name user in the Spring security module. Let me show you the properties of this class. This is the user class which is having username, password, authorities, set of authorities which is of type granted authority, then few other properties that are relevant to the account. So we are trying to create a replica of this user with the name app user. We are not going to add all the properties. Let us add few properties like user ID, username, password, set of authorities. Authorities are nothing but roles. If you want to authenticate the user with username and password, you can use that. If you want to authenticate the user with email and password, of course you can do that also. But the inbuilt method name will be load user by username. You should not be intimidated by that. You can either use email or username. So let me add the properties first. This user ID is going to be the primary key. So let us add at ID annotation. I want this to be auto generated. So let us also add at generated value. Let me also add at entity annotation. All these annotations are from jakarta.persistence package. Already we have seen it in the first video. Together with this, let us add a set of authorities. This is of type set of string. In this case, it is a set of string. But when you are creating a user object, that is the inbuilt user object, which is implementing the user details interface, you need to pass the authorities as a set of granted authorities, not as a set of string. While doing the application, we will get to know. So here let me give it as authorities. Since we are using set, let us use the annotation at element collection. Together with this, let us also add the next annotation at collection table to specify the name of the join table. Already we have learned how to implement set in case of a spring-data-jpa application. I assume you have gone through that, where we are using element collection and collection table. In case of collection table, we need to pass the name of the table and also the join key column name. In case of collection table, it takes two attributes. One is name, the other one is join column. The name represents the name of the junction table. The attribute join column is used to specify the column with which these two tables has to be mapped. The table name is user underscore authorities. The next attribute is join columns. At join column and pass your column name. Name equal to user underscore ID. Now let us also add getter setters and toString for this class. Together with this, let me also add a parameterized and a default constructor. Go to source, generate constructor from superclass. Since I want a parameterized constructor, I am adding the default constructor also. Go to source, generate constructor using fields. User ID will be auto generated. So I am supposed to pass only these 3 parameters. Now the app user class is ready. Let us create the app user repository. Select the repository package, right click, new interface. The repository name is app user repository, annotated with @repository, and this extends JPA repository. Pass app user as parameter, and the second parameter is integer. One more thing is, in our case, the class name is app user. A and U are capital. So when the table is getting created, the table name will be app underscore user. So let me change that. I don't want it with an underscore. At table name equal to app user without any underscore. Okay, let me come back to the repository. Import app user. We will discuss the method that has to be added to the repository later. Let us complete the service layer before that. Select service, right click, new class. The class name is app user service IMPL, which implements user detail service. It should be annotated with @service. Okay, fine. So what is the method that we are going to add over here? The method that is available in user detail service should be implemented by app user service IMPL. So let me click on this. The method that is available in user detail service is load user by username. This method is used to authenticate the user. When the client enters the username and password, the class that implements this user detail service will be called automatically, and the control will enter into this implementation method. From here, we will be calling the method of app user repository to check whether the username is available in the database or not. Okay, we will start writing the code. You will get to know when you are testing the application. So in app user service, let me keep the cursor, add unimplemented method. So the method name is load user by username. The client is entering the username from the browser or Postman app or from any other application to this particular REST API, means automatically this method will be called. Within this method, we are getting the username and checking whether the username is available in the database or not with the help of the repository interface. If you notice, the return type of this method is an interface, user details. Let me click on this. User details is also having few methods: get authorities, get password, get username. Let me go back to the user class, which is the inbuilt class. Here you can see user implements user details. Whatever methods are available in user details is implemented properly by the user class. So in our case, whenever I am getting the username from the client and sending it to the database to check whether the username exists, it is going to return me an app user object. I need to retrieve the app user object and then convert it into a inbuilt user object, because this user class only implements user details. Our app user is not implementing user details. So we need to take the values of app user and create the user object explicitly and return it from the method. Let us see how this can be done. And also here you can see the method throws username not found exception. It is an inbuilt class which is already available. This exception extends authentication exception. Let me open it. Authentication exception extends runtime exception. It means username not found exception is a runtime exception. You don't have to handle it using try and catch. Okay, let me go to app user repository. Let me write the derived query to get the user by username. Find by username. It takes string username as parameter. Let us add the return type as optional. It takes app user as parameter. Import optional. In my case, I assume that the username is unique. So we need to add that information also to the app user class. So above username, add the annotation at column unique equal to true. Okay, going back to app user repository. So this method is completed. Now let us call this method from app user service IMPL. Let us auto-wire app user repository. Add the setter method together with that auto-void annotation. Create a constructor to add to auto-wire this app user repository. Now let us write the logic for this load user by username method. App user repository dot find by username. This returns an optional. If the object is available, it will return the object. If the object is not available, it has to throw an exception. So let us also directly call dot or else throw method. It takes supplier as parameter. You can throw the exception. Throw new username not found exception. Username does not exist. The return type of it is app user. Here no need of throw keyword because we are writing it in a single line. Now we need to return an object of the class that implements user details. The inbuilt user class implements user details. So let us create an object of user. User is equal to new user. I'll go in for a parameterized constructor which expects username, password and a collection of granted authority. So we have to extract these values from app user and pass it to the user object. String username equal to app user dot get username. Get the values from app user object and create a user object. Next the second one, string password app user dot get password. Next is we need to get the set of authorities. In our case it is of type string. We have to convert it into set of granted authorities. Let me first get the authorities from the app user object. Now we need to create a set of granted authorities object. Granted authority G authorities equal to new hash set. Iterate through authorities and add it to G authorities. Authorities dot for each pass authority reference. This granted authority is an interface. So we need to use the implementation class of granted authority. Let us use the simple granted authority. So we need to create an object of simple granted authority and add it to granted authority object. Here inside, let us create a reference of granted authority. Auth equal to new simple granted authority which takes role as parameter. In the next line, add this object to granted authorities. Granted authorities dot add auth. Let us now modify this logic using Java 8 map method. For this, let me convert authorities into a string because authorities is a set dot map. Map takes function interface as a parameter. In case of function interface, it takes an input of one type and converts it into an output of another type. In our case, the input that is coming into a map is of type string. The output that is going from the map should be of type simple granted authority. Before doing this, let us see a simple example. I will do with the same authorities. Authorities.stream.map. The input to the map is of type string. So str. The output from this map, what I need as of now is the length of each and every string. So I can give it as str.length. In our case, the set of authorities has the values as admin and user. So the input is admin, the output is the length of admin. Input is user, the output is the length of user. For each and every string, the length will be collected and it will be converted into a list. So the method will be dot collect collectors dot to list. This is how we need to implement map. In this case, the input is str. The output should be a simple granted authority object. New simple granted authority object which takes this str as parameter. In our case, str is nothing but role, so I'll just pass it as role. Dot collect. Let me add it in the second line. Collectors dot to set. In our case, we are trying to convert it back into a set. The return type is a set of granted authorities. So already we have created granted authorities object. So let me give it as granted authorities equal to. I'll comment this line. So I hope this is clear. You are converting your authorities into a stream. You are converting your set of string values into a stream using the map method. The input to a map is of type string. The output from a map is of type simple granted authority, and we are converting it back into a set of granted authorities object. So now we have got all the properties that is needed to create a user object. So if you notice, this user object expects three values. You just keep the cursor and control space. Username, password, and collection of granted authorities. So we have collected all the three properties. So let us pass the properties. The first property here is uname, password, and the third property is granted authorities. And finally, we can return user, since user is an implementation of user details interface. Since we are implementing it using Java 8 map, I will comment this part. Now this code is completed. Okay, the method that we have implemented now is to retrieve the users by the username from the database. But we don't have any users in the database. So we also need a method to add the users to the database. So let me add one method. So this is a own method of this particular user service IMPL class. It is not from user detail service. We are creating it as our own method. Public app user add user. Pass app user as parameter. Return app user repository dot save by passing the user object. Okay. Now our service class is ready. Next, let us move on to create the controller class for this app user. Select controllers package, right click, new class. Let us give the class name as app user controller. Annotate it with @REST-controller. And let us add the method for adding the user to the database first. Public app user save user. Let us use post mapping / app users. Add @request body annotation. Now we need to auto-wire app user service IMPL. Since we don't have the interface, we will be directly auto-wiring this class. Private app user service IMPL. Add the setter method and add @auto-wire annotation. Now we need to call the add user method of app user service IMPL. Before doing that, from the client, when we are getting the app user object, we will be getting the username, the password, and the authorities. In case of password, it should be encoded before being saved to the database. For encoding the password, we need a bean of password encoder. That should be added to the webconfig class. So before doing this, let us create a webconfig class. Select com.bookapp package, right click, new class. The package name is com.bookapp.config. Class name is webconfig and click finish. Annotate it with that configuration @enable web security. Now within this, we need to create two beans. One is for authentication and the other one is for authorization. Let me add the code just like how we have done for in-memory authentication. The first bean is user detail service bean. We will write the code later, but let me add @bean annotation alone. Similarly, the second one is authorization bean. This is a bean for security filter chain. Let me give the method name as configure, which takes HTTP security as parameter. We will write the code of this also later. Let me add @bean annotation. Now let us add a bean for password encoder. Public password encoder. Return new bcrypt password encoder. And this should be annotated with @bean. Rest of the code we will write later. Now what I wanted is this password encoder bean. Now what I will do is go to the app user controller, auto-wire password encoder also. Private password encoder Add the setter method, auto-where it. Okay. Now from within this, let us write the logic. Let me get the password. String password equal to app user dot get password. We need to encode the password. String new password equal to password encoder dot encode the old password. Okay, similarly, let me get the username also. App user dot get username, and let me also get the authorities. Set of string authorities. App user dot get authorities. After getting everything, let us create a new user object. Let us create a new app user object equal to, let me use the parameterized constructor. I am selecting the second constructor which takes username, password, new password and authorities. Now call the add user method of the service class. App user service impl dot add user by passing the new app user object. We need to return the object that is added, the database. So add the return statement also. So now the app user class is also complete. Okay, what about the next method? There is one other method over here in app user service impl, that is load user by username. We are not going to call this from the controller because the moment you give the username and password, automatically the webconfig class is responsible for calling this method to check whether the user is an authenticated user. So we have to add the details of this particular class in the web configuration file. In which place? When you are creating a bean for authentication. Let us go to the web config file. Here, let us return an object of the class that implements user detail service. When you are working with in-memory authentication, you use the class called as new in-memory user details manager. In this case, we have created a class which implements user detail service. So this class is responsible for authenticating the user. Let us pass an object of this class, return new app user detail service impl. This expects an object of app user repository. If you have to do this, then in this case, you need to again auto-wire app user repository. But if you notice, already we have auto-wired app user repository in app user service impl. So instead of having a parameterized constructor, let me add at auto-wired here directly. Do not worry, I will just show you how to do with the parameterized constructor also. But as of now, at this junction, let us not use that. Too many things means it will be confusing. Now let me come to web config. In web config, you are just returning an object of the class that implements user detail service. Okay, the authentication bean is ready. Next is we need to write the code for authorization bean. Let us add the code. It is just similar to the code that you have done in in-memory authentication. http.csrf.disable.authorize HTTP request. We are working with Spring Boot version 3.1.x. So you need to use authorize HTTP request method. Let us go in for the second method which takes customizer as parameter. Customizer is a functional interface. It has one method customize which takes a parameter to manipulate the input. So let us also pass a parameter as auth, and let us write the code for authorizing the URLs based on the roles. Auth dot request matches. We need to pass the URL. Before that, let us call the method called as permit all. In this case, identify a URL which can be accessed by all the users without authentication and authorization. Let me open the book controller. Let me check if there is any URL which can be seen by all the users without authentication and authorization. I don't have anything. All the URLs should be authorized. Let me open app user controller. Here I am having a URL as app users. This is for adding the user to the database. Whenever a new user is signing into an application, you will be getting his credentials to save it in the database. So it means, so this URL should be allowed to be accessed by all the users without authentication and authorization. Let us add this URL to the request matches /app users. Next, auth.request matches. This time we need to pass few URL patterns that can be accessed by both admin and user. And the last one, we will add the URL pattern later. auth.request matches has role as admin. Now let me go to the book controller. We need to identify what are the URLs that should be accessed by admin and what are the URLs that should be accessed by the user. So in our case, the first two methods can be accessed by the admin. The last three methods can be accessed by the users. But in our case, all the URLs start with the same URL name /book-api/books. Just to differentiate, here let me add the URL pattern starting with admin /admin/books, and in this case /admin/books/id. In case of user, let us have the URL pattern as /user/books, and for author and category also let me add it. Remember, the top URL is book-api. Go to web config. Let us add the URL book-api/admin/*. Here /book-api/user/*. And after this, .form login .and .build. Add the return statement. This method throws exception, so add throws declaration. So we have added 3 beans. One bean is the password encoder. The other 2 beans are for authentication and authorization. Together with these 3 beans, we need to add one more bean for authentication provider. This is just to inform Spring framework what type of authentication we are using. In previous case it was in memory. Here it is database specific authentication. So we have to inform clearly what type of authentication we are using. So let us create a bean for authentication provider. Authentication provider. Let me add the method. So the type of authentication that we are using is DAO authentication. Let us create an object of DAO authentication provider. To this authentication provider, we need to set the password encoder and also user detail service, because they are properties of this DAO authentication provider. Let me click on the class. You can notice that the password encoder, user detail service, they are properties of DAO authentication provider. Already we have created a bean. So using that, we can call the setter method set password encoder by passing encoder method. Then provider dot set user detail service. Pass the method user detail service and return the provider object. This class should be annotated with that bean. So we have created a bean for authentication provider also. Just to inform what type of authentication we are using, that's all. All set, the configuration class is ready. We have also completed the controller class. Let me open the model class app user. In case of the annotation at element connection, because we are using a set of authorities, the fetch type will be lazy by default. So you need to change it to fetch equal to fetch type.eager. Of course, we can do this, but I want to show you the error first and then we can modify the code. Let us start the application. Now here you can see the app user table is getting created with user underscore ID, password, username, and app user underscore sequence for the sequence table, and user underscore authorities, which is taking user ID and authorities. User ID is the key to map the app user table with the user underscore authorities table. All set, the table is created. Now in the next video, we will test this application using Postman and the browser. Let us also check whether the table is created in the database. Let me open mysql command line, show tables. describe app user, describe user underscore authorities.